Hi everyone, welcome to the Earth Science Regents Review podcast series created by Homick's Middle School Earth Science Department. Today we're going to be talking about the topics of the seasons and revolution. So before we get started, it's important for you to know the difference between revolution, which is our trip around the sun, and rotation, which is going to be the spin of the axis. Make sure you know the difference between those two motions and the characteristics that go along with each of those motions. Well, first off, the characteristics of revolution, which we're going to focus on in this podcast. Okay, we revolve around the sun about a degree per day. We travel once around the sun every 365 days, so it turns out to be about 1 degree per day in our trip around the sun. Okay, anything to do with revolution is going to be associated with the months, the years, and the seasons. Any one of those three factors is directly related to revolution. And finally, we revolve around the sun counterclockwise. So constellations, which are pictures in the sky created by stars, they help support the idea of revolution. Certain constellations in the nighttime sky are seasonal. You only see them during different times of the year. Orion, for instance, is a wintertime constellation. The reason for this is that the sun gets in the way. We only see Orion in the wintertime because of the fact that it's in the nighttime sky. The sun doesn't get in the way. In the summertime, we don't see Orion because the sun does get in the way. That supports the idea that we revolve around the sun. Now, there's a couple reasons for the seasons. The number one reason for our seasons is the fact that our axis is tilted 23.5 degrees. That little angled tilt is just enough of a difference for the sun's energy to hit the earth through our revolution around. So we get winter, spring, summer, and fall because of our tilt of our axis. A close second is going to be revolution. If we didn't revolve, we wouldn't have any seasons. We'd be stuck in one season throughout our eternity. So revolution is a real close second in terms of our reason. Because of our revolution, it allows the sun's energy to hit the earth differently. That creates our different seasons. And then parallelism at the axis. That's a fancy way of just saying that the axial tilt, specifically the north axis, always points to Polaris at every point throughout our revolution. So a couple terms you need to know about the zenith. The zenith is going to be the point directly above you. That's important because there's certain latitudes where the sun actually hits the zenith on certain days. And when we talk about the sun, we have to talk about the sun's energy. It's called insolation, incoming solar radiation. We like to call it, just in class, we like to call it the sun's energy. Easy way to remember it. So when we talk about the zenith, there's certain latitudes where the zenith is hit. And those latitudes are found in what we call the equatorial region. That region, the north part of that is the 23.5 degrees north to Tropic of Cancer. The south part of that region is 23.5 degrees south to Tropic of Capricorn. That zone is only the zone where the zenith is going to be hit at every day of the year. That also incorporates our equator as well. You only need to know 3 latitudes on 4 days. Tropic of Cancer, the equator, the Tropic of Capricorn. And you need to know those latitudes, what day the zenith is hit at those latitudes. We'll talk about that coming up. So that equatorial zone is going to be the important area on the earth where the zenith is going to be hit consistently. So here's what you need to know. The northern hemisphere summertime is found on June 21st. It's called the summer solstice. We get 15 hours of daylight on this day. It's our first day of summer. The zenith is going to be hit at 23.5 degrees north. That is our Tropic of Cancer. On that day, the sun is directly overhead at the zenith at that specific latitude. On this day, because we're tilted towards the sun, the North Pole gets 24 hours of daylight, and the South Pole gets 24 hours of darkness, because they're tilted away. This is a position of the Earth compared to the sun called aphelion, because we are farthest away from the sun around this season. Actually, aphelion actually occurs on or about July 3rd, so it's around the time of the summer solstice that we are currently going into aphelion. We compare that with the winter solstice, which is the first day of winter in the northern hemisphere. That's going to be December 21st. Well, because it's our winter time, the direct sun is going to be at the zenith at 23.5 degrees south, the Tropic of Capricorn. Okay, on this day, because we are tilted away from the sun in the northern hemisphere, our North Pole gets 24 hours of darkness. The South Pole gets 24 hours of daylight. This is a position of the Earth compared to the sun that we're technically getting closer to the sun at a position called perihelion. Perihelion actually occurs on or about January 3rd. So know the difference between the winter solstice characteristics and the summer solstice characteristics. They're exactly opposite. Here's what you need to know about the equinoxes. The vernal equinox, which is the springtime, and the autumnal equinox, which is the fall time. Really easy. The entire planet from North Pole to South Pole gets 12 hours of daylight and 12 hours of nighttime. And the latitude that gets the most direct sun on this day is going to be the equator. The equator is going to have the sun at the zenith on those 2 dates. So you can see here where the sun's energy hitting the North Pole, the equator, and the South Pole. You can see how the sun's energy is very spread out at the North Pole. It'd be the same at the South Pole, okay, compared to the equator where it's very, very concentrated. The more concentrated the energy is, the higher the angle of insolation, the stronger the sun's energy is going to be, the warmer the temperatures. That's why the equator is so warm and the South Pole and North Pole are so cold. The angle of insolation is much lower. So you can see here, if you're at the North Pole or South Pole in their respective times here, you would see that the sun's energy hitting the roof there is very spread out, very low angle of insolation here. It's going to be very cold. We compare that with a place near the equator where the sun's energy is going to be almost at a 90-degree angle here, okay, or pretty close to it. That energy is much more concentrated. That's why it's much warmer. So what's going to be important here is to be able to identify with a picture like this, a diagram like this, what season is which. So when you take a look here at position number 1, you see the northern axis is tilted towards the sun. That is going to be our summertime in the northern hemisphere. Notice that the North Pole is in 24 hours of daylight. Position number 2, that's going to be our winter time. You notice that our northern axis is tilted away from the sun. North Pole is in 24 hours of darkness. Once you figure out summer on the left and winter on the right, you go counterclockwise around the sun. Very easy to figure out. Position 3, okay, that is going to be springtime. Position 4 is going to be fall time. So from position 1, okay, that's going to be summer. Position 2 is winter. Position 3 is spring. Position 4 is fall. And you can see with position 3 and 4, if you look closely, the terminator line, which separates day and night, goes directly through the middle of the North Pole in both cases. So you can see position 3 and 4, those are your equinoxes. Position 1 is your summer solstice. Position 2 is going to be your winter solstice. Okay, with that being said, hopefully this helped you out understand the seasons a little bit better. Make sure you look at the sun's path. It's going to be very similar to this. Make sure you look at that podcast. That'll kind of help you out in terms of understanding the seasons on a little bit more of a daily level. With that being said, good luck on your exam, and thank you so much for your time. Bye-bye.